Okay, guys, this is another target round problem, which is actually a really nice question. I love this problem because we have a really nice relation at the end. You will see it. So if you didn't see it in the first place, go ahead and read the question and try it before I do it. Okay, make sure you always do this every time that you watch a video. This is just another reminder. Okay, so we are a triangle DEF. Okay, let's start with labeling them. And the sides are integers, right? This is one of your biggest hints. Okay, this is really important. And the perimeter is 40. Okay, that will be the sum of those three numbers will be 40. And we have circles with a diameter of DE. Okay, this guy is diameter, which means this is going to be my half circle. And then EF is going to be this half circle. As shown, if arc DEF is also another half circle, you know, this guy right here is also another half circle. And what is the area of the shaded region? Okay, so before we get started, as I always remind you to remember some of the Pythagorean triples, because as soon as they said this is a integer side, then I can think about my Pythagoreans, okay? Pythagorean triples. So I have 5, 12, and 13. I have 3, 5. Actually, I have 3, 4, 5. That was my first and the most important triple that I need to remember. If I add these guys, you know, that's, what's that? So 12. 12 is not 40, or if I multiply 12 by anything, I cannot get 40 at all as integer multiple. If I add this, that's going to be 17 plus this 30. So it's not 40. So my next triple that I need to remember is 8, 15, and 17. So if you combine these, that's actually 32, 40. Yeah, this is going to work. So since this number is 40, that means this triangle actually 8, 15, 17, because we are told that's integer. So these guys will be 8 and 15. And this guy should be 17. So some people may say, is that has to be 8 and this has to be 15? It doesn't really matter. So based on how that looks like, since this is like kind of larger, I can go with 15 and 8, or I can do the other way around, which doesn't really make any difference, okay? But anyway, so these are important, so triples. And as soon as we have this one, we like to find this shaded region and this shaded region, right? But it doesn't look like this is a shape that I do know some approach or some formula, if you want to call it, to find that region. Then I need to do something else. I need to be smart, okay? So if you don't have anything, then we make something with different, okay? So what I'm gonna do, you know, I'll try to color this. So think about this half circle, okay? And then now think about this half circle. Okay, and if you look at these two half circles and then combine the triangle, okay, and if you add those three, like this half circle, and this right triangle, if you combine them all together, that would be everything that we see in this figure, right? But at the same time, if I subtract the half of this larger like circle, do you see this guy? This is a really nice circle. We are told this is also, the EF is also like semicircle. So if I subtract this white region from this whole region, it's gonna be actually my shaded region. So I hope you see what I'm talking. So let me try this. So I'm gonna write it here. So shaded region is equal to the area of this half circle. So let me keep it kind of organized. So think about, again, it doesn't have to be a really perfect figure. So think about this half circle plus, okay, and then I have another half circle, which is gonna be kind of in red, that one. And then I'm gonna have a triangle. Okay, so maybe I should use maybe different color, but anyway. So let's say this is my, So if I combine all these three, that will be whole region, right? Okay, but let's actually kind of organize our way of coloring. So this I was there. And then if I subtract now from these three, okay, I hope it will make sense to you. So if I subtract the area of this circle, like half circle, actually, so that would be something like this. And like this circle, like half circle, plus this half circle, plus this triangle will be whole region that we saw, minus the half of this circle, like that is the center at DF. So if you want to really label it, this corner is D, this is F, and this is E, and that's F, and that's D, that's E, F, D, and E. At this point, you really need to see that subtraction will give you that shaded region. If you don't see that yet, please don't move on. Just convince yourself before you move on, okay? And then we are gonna continue. So this region is just the half circle, which is, the circle has the area of pi times radius squared. So that will be pi times radius of 8 is just 4. So that's 4 squared, but I need to take the half of this back. Okay, and next one is also half circle, which is the radius is 15 half. So pi times 15 half to the second power. And this guy will be divided by 2 because we have a half circle. Okay, and the next one is a triangle, which is a right triangle. The leg is 8 and 15. So that will be 1/2 times 8 times 15. Okay, and the last one is also a half circle, which is this one. Maybe I should kind of color this as well. Okay, so this is also half circle, and the radius is 17 half. So I should put in this as well. Okay, so that would be 1/2 times I times the radius is 17 half pi r squared. So if you simplify this one, let's see what's going to happen. Okay, but if you don't want your life miserable, look at the things that you have. So this is 4 squared, right? And then this is 15 over 4 because this square that would be 15 over 4. And then we have 17 over 4 as well from here. So I think like if you combine those together and then maybe deal with this after, that might be useful. So let's look at this one. I do have 16. Okay, so 16 I over 2. Just keep that in mind. And then I have a fraction. So 15 over 2 squared is 225 over 4. So that will be 225 pi over 4, but that was divided by 2 as well. So I just leave it that 2 as for now. And the last one was minus. So if you square 2, like 17 over 2, that will be 289 over 4. So 289 over 4 divided by 2. Okay, so let me see if this is gonna be useful so far. So we had 4. Okay, that's 17 over 2. Okay, so I think it looks good, right? Let me double check. So that's 16, that's 15 to 25. Okay, so now, everything like in numerator was like having 4 in the denominator except this guy. So instead of 16, I'm gonna actually rewrite this guy in the same format. 16 pi is actually 64 pi over 4. So you will see now why I'm doing this in my next step. So this guy, if you combine all those numerators, 64 pi over 4, 225 pi over 4. If you combine these two, actually 64 plus 225 is 289. The sum of these two guys, 289 pi. And then this guy has also pi because, this is multiplied by pi. So basically this guy plus this guy minus this guy is just 0. So sum of these three is actually a really nice number. Okay, that's 0. What does that mean for us? So this guy, this guy, this guy add up to 0. What's left over is just this part, which is gonna be 1/2 times 8 times 15. So these guys will be canceling each other, so that will be 16. And then I hope you had a aha moment in some part of this video. If you didn't have that, that's okay. But I want you guys to look at this answer. Like we did a lot of different like subtraction, addition to get that shaded region. But at the end, our answer is really straightforward without really having any pies or some fractions. And look at this number, like this was 1/2 times 8 times 15. This is actually the same as the area of this triangle because that's 8, that's 15. So if you look at that one, that's actually the same as that shaded region. From this problem, you may guess the area of this triangle is actually the same as the sum of those two shaded regions. But this is a guess, and I want you to take some time and prove this. How can you prove it? You can make 8, 15, and 17 as some unknown. Let's say this is A, this is B, this is C, and do the process exactly what I did, and see if you can get the area of those two shaded region is actually equal to product of this leg and this leg and divided by 2. If you can prove that, then you can consider this, you got really this question, okay? But otherwise, it's gonna be okay as long as you are fine with this solution when you have those concrete numbers, okay? So I hope that makes sense, and I'll see you next time.